Thank you, sir. Thank you so much. And very good afternoon to all the participants over there. Am I audible, sir?
Yes, yes, you're audible. Perfectly.
Okay, thank you so much. So now we are going to discuss a very interesting tool that is online simulator, and with the help of that, you can simulate different hardware components, and you can teach kids, students using those online simulator in a remote learning also. That will be very helpful. So let's get started the tool that I'm going to discuss, and over there we are going to talk about programming in a two mode, like in embedded C or C++ programming, or in a Python also, because now in this day when we talk about Python, that is so much popular because that is very easy to use. Now that Python is being taught in a school also, like those kids, those coming in the colleges or in the diploma or engineering colleges, they are already familiar with the Python. So how we can inculcate new skill set, some hardware skill set using that Python programming and using some online simulator and free simulator tools that I'm going to discuss over here. So let's get started. So first of all, the tool that we are going to use over here, that I'm going to discuss over here. So the name of that online simulator is, that is WOKWI, WOKWI, so that you can see it over here. So this one is a tool over there, which hardware we can simulate it over there, so that we are going to discuss. So first of all, there is a Arduino Uno board. Might be you are familiar with the Arduino Uno, so that we can simulate in the Tinkercad also. That is another simulator. But over here also in this tool, that we can simulate Arduino hardware. Then after that, there are some more add-on things over there that we can use it. That is Arduino One advanced board that is being used in advanced projects. That is Arduino Mega. That also we can simulate it over here. I mean, we can make any project based on these boards. Then after that, there is a ESP board. So in a ESP series, that is Wi-Fi based board for the IoT applications, because in the Arduino we are going to build some embedded based projects. But when we have to connect with the IoT application, we need Wi-Fi connectivity, so that we cannot do it on the Tinkercad or any other simulators. So for that, we can go with the ESP module. So ESP board, that is ESP32 board, that can be used over there. Then after that, there is a Arduino Nano also. Like if we have to make any low cost product or low cost project, that also we can make it using Arduino Nano also. That is the smaller version of Arduino Uno, because sometime when we are going to use for learning applications, we are going to use Arduino Uno board. And when we have to build any project or we have to deploy it in any project, so we have to go with the Arduino Nano for low cost budget. And same thing we can implement it, that already we have implemented in the Arduino Uno. Then after that, there is a very interesting board that is being recently launched by Raspberry Pi. So when we talk about Raspberry Pi, and when we are going to heard about the word of Raspberry Pi, so we are going to talk about microprocessor, because Raspberry Pi is so much popular in the microprocessor for doing multiple tasking and making a desktop based computer using Raspberry Pi. But now recently, 1 year back, they have introduced microcontroller also. They are pioneer in the microprocessor, but now they have introduced, that is microcontroller, with the name of Raspberry Pi Pico. So when we are going to compare that Raspberry Pi Pico as comparison to the Arduino Uno, so the cost of that Raspberry Pi Pico is very less. That is approximate 230 rupees. Within 230 rupees, you will able to develop any kind of product based on the Raspberry Pi. And some more add-on over there is that you can program in the Raspberry Pi Pico board using Arduino software also. Meaning in C++ language also you can program it, and simultaneously you can program in this Raspberry Pi Pico using Python also. That also you can use it over here. Then after that, the same ESP32 board, that we can program it using C++ language, and as well as we can program this board using Python also. And there are a few more microcontroller board also that we can use it over here. So that you can see it over here, that is 8085. That is one of the smallest microcontroller, not one of the, but that is smallest or low cost microcontroller that we can program it using Arduino hardware also, Arduino software also, and we can make it very cheap project using this 8085, because the cost of that 8085 microcontroller board is approximate 30 rupees. 30 to 40 rupees we can get that microcontroller, and we can make any low cost project using that 8085. Then the Pico board that we have discussed over here, that is Raspberry Pi Pico, and we can use this directly, that microcontroller also, that Pico microcontroller. Then you can use Circuit Python on the Raspberry Pi. Circuit Python is a simple Python programming, that also we can use it over here. And JavaScript also we can use it over here in this Raspberry Pi Pico boards. So these are few more add-on over there. So how you can use this software, that is very interesting, and that I'm going to discuss over here, and I will share with you some example also that we can use it over here. So there are few examples that you will find it over here. And when we talk about the comparison, as we are going to do it with the Tinkercad is a little bit user friendly. But when we talk about this WorkV tool, so over there you will find more add-on components, because over there in the Tinkercad there is a limitation of the components, but over there you will find many more component, and you can make any kind of complex project also over there in this. Like you have to integrate that Adafruit SSID, that is LCD, color LCD, you have to integrate it. Any kind of LED pattern kind of display you have to add it, that also you can add on over there. And then after that you will find some more example also over there. Like if you have to make a piano using that Arduino board, that we can make it on the Tinkercad also. But some more add-on, like if you have to do Python programming, that also you can do it over here. But in the Arduino we can do only C++ programming, but in the ESP32 board we can go with that Python programming also. So any kind of game we have to make it, any national anthem we have to play it using that buzzer, that also we can make it over here. So this one is a piano, mini piano, that also you can make it. And there are few more projects, like any kind of servo based dancing robot you have to make it, some pattern you have to make it, some clock you have to make it, that also you can make it. So now we are going to discuss about this tool, how this tool is working and how we can use it. So this one is about detail of this tool. That is the document of this tool. This one is an open source tool. Like if any modification you want to do it, that also you can do it, and that is totally free tool that we can use it over here. So over there I'm going to see the detailed documents. All the detailed document, each and everything, you will find it over here in the public domain. So over there, like if you have to work on the environment of development environment, or if you are going to change that environment, you want to modify it, you want to change the background color, each and everything you can modify in the document over here, that you can do it over here. And if you want to install it in your computer for modification, each and everything you will able to do it. So now that is about the internal part of that WorkV tool. Now we are going to discuss over here that how we can use it. So first of all, when we have to start with any kind of board, so we have to select that board, and after selection of that board, we will able to program that board. So first of all, I'm going to start with the Arduino board. Then after that, I'm going to use the ESP board also. Then we are going to discuss about Raspberry Pi board also, and then we are going to discuss about micro Python coding also. That is similar coding we are doing in the Python, but there is some add-on over there. When we talk about micro Python mean something we have to deploy it on the microcontroller. So over there some inbuilt function you will able to find it, and you will able to use it over there for writing any kind of code. So now we are moving ahead over there with the simple board, that is Arduino Uno. So as we are going to click it, Arduino board is being get open over there. First of all, you have to be get familiar about all the functionality of this simulator, that how we have to add component and how we have to make a circuit diagram. And then after that, how we have to write code over there. So that is very important over there. So that we are going to do. So first of all, over there, you will find all the programming feature. So that is IDE, integrated development environment. Over there, you can write your code. If you are having your own code, that is already, if you are having, so that code you can use it over here. Means that you can paste your code and you can deploy it directly on the software. You can verify your code and you can simulate it. And after simulation, what you can do it, you can test it on the real-time hardware also. So over there, first one over there in this ID, that is sketch.ino. So whenever we are going to upload any code in the Arduino, that is in the format of INO, because Arduino code, whenever we are going to write it in the Arduino software, that file format should be .ino. So now after that, there is one more option over there, more window over there, that is about diagram. So this one is about coding window, and then we are clicking over there in the diagram.json. So over there you will find that options, that is about the diagram. So if any modification we want to do in the diagram, so that also we can do it over here using these keywords over there. So I will let you know how you can do few modification over there. Then after that, library manager, if you want to add on any library in the Arduino, so that also you can add on over there. For that you can click plus and you can search over there library, like I'm going to search over here that THT double one. So the DST double one or double two sensor library we want to add on over there. So select that library, and that library is being get added over there, installed library. So whatever sensor you are going to use it over here, that library you can add on over there easily. So library text also you will able to find it over here, DST double two library over there. So then after that, this one is a library manager that we have discussed, and this one is a diagram, this one is a sketch. Now we are coming back to this board. This one is a microcontroller board that we have selected earlier. So how we can make any circuit? Just take an example of LED blinking that we want to do it over here in this Arduino board, and we are going to blink any LED on any digital pins. So these are digital pin and these are analog pins over there. So what we have to do it over there, we have to go with those digital pin, and we have to select components. So where we will find that component library, that is very important. So for that, what we have to do it, we have to go to this option, that is three dots that you are able to see it over here. Click over there. That option you will find about zoom in, zoom out and all that. Then after that, there is an option of plus button. In plus button, you can add components over there, you can add sensors over there, you can add actuators over there in this board. So that I'm going to click it. Then you will find, again repeating, as we are going to click it, a new pop-up window will be visible over there. In this window you will find all the component. So like if you want to search any component like resistance, you will able to find it over here, and PIR sensor you want to search it over here, LDR sensor, that is also available over here. Then you are going to search relay, that also you are able to get over here. Then you are going to search battery is not required over there. Then you can go with the buzzer, then we can go with the TST sensor, that also you will able to find it. So maximum component you will find it like RTC you will not find in that Tinkercad or any other simulator easily. So you will able to get that RTC also over there in this board, like LED, dot matrix, LED display, OLED, that also you will able to find it. Recently I shared with you that LED, that was OLED. Now in this day, when we are going to make any kind of commercial project, so over there we are going to use that OLED. So these are the different type of LEDs, that LED display board that I'm talking over here, not a simple LED that you will able to see it over here, NeoPixel LED. So now when we talk about all the components, so all the component you can see LED, push button, resistance, slide switch also over there. You will not find their diagram directly over there, but you will able to see their name. Keypad, logic analyzer, 8 channel. So then after that, dot matrix, neopixel, ring, neopixel meter, buzzer, DST sensor. So DST sensor is being used for temperature and humidity monitoring over there. Then potentiometer, then slide potentiometer, then LCD in a different format. So there is a two LCD. This one is a 16 into 2. So over there 8 pin is being used for interfacing with the Arduino. But there is one more LCD, that is I to C. Mean for that only 4 pin you have to use it, and you are going to use I to C communication over there. Then 20 into 4. Then this one is also I to C, servo motor and rotary dialer. Then OLED display, TFT LCD display also you will find it, RTC ultrasonic sensor, RGB LED 7 segment display in 4 digit, 2 digit, LED bar graph, analog joystick also you will find it, IR receiver, IR remote, PIR motion sensor, then analog temperature sensor like NTC, then shift register, So that also you will find it over here. Input shift register, tricolor drivers, LDR sensor, then rotary encoder, then accelerometer and gyroscope also you will find it over there. Micro SD card, DP switch, DP-DT relay, that also you can use it over here. PLTV and all that. So these are the components that you will find it over here in this uh, simulator. So first of all, we are going to start with the LED. So click on this LED and you will able to take LED over there. So you can see LED is visible. So wherever you want to place that LED, you can place it as per your requirement. So now after that you have to connect their wiring. So how you can connect it in the same way like we are using in other simulators. So we have to say this one is one wire, this one is second one, this one is a negative, this one is a positive. So this one I'm going to take it and I'm going to click it with the ground like this. So we have completed it. Now we have to take one resistor. So we are going to take resistance over there. So by default that resistance is being get selected, and now so over there you will find more properties in this diagram. Like if you are going to change that resistance value over there, so that also you can change it. So this one is a LED one, so LED board, then this one. And when we talk about LED, you can see LED over there, LED top, left, attribute of that LED. And in the attribute, you can see color, that is red. So I'm going to change that color attribute, that I'm going to make it green. Now you can see LED color gets changed over there. So that you can see it over here. So whatever color we want to use it over here, that we can use it. Arduino, so their attribute is over there. Then after that, the resistance we are going to use it over here. So resistance value, so right now you can see this one value of that resistance is 1 kilo ohm, that is brown, black and red. We want to use over here only 220 ohm resistance. So what we have to do it, so this one value we are going to change it, that we want to use it 220 ohm. Now you can see automatically color code of that resistance will be get changed. Mean if you want to change the properties of that component, for that you have to go to the diagram, and over there you have to change the properties of that specific component over there. So type, top, left, attribute, each and everything you will able to find it over here. So like if you want to rotate it, so over there you can change the attribute of that specific component over there. So now after that we are coming back to connect this resistance over there with this. So if you want to know about more of this resistance, that how you are going to operate it, so there is a question mark. As we are going to click on the question mark, you will able to read more detail about this resistance, like how you are going to use it, what is the name of this, what is the default value over there. So you can see the value in attribute, so that you can change it value 1, value 220, 1000. So accordingly you can change the value. Simulator example also you will find it over there. Edit this page, but we don't want to edit it. So and few more thing over there. Yes, so that is pin description, first pin, second pin, so that you no need to change it over there. So all the description you will find it, attribute you will find it, value you will find it. Okay, so now coming back to this simulator over there, and we are going to connect it like this. And this one I'm going to connect second end over here with any digital pin you can take it. So right now I'm going to take it 12 number pin. So 12 number pin I have taken it over here. So 12 number pin I have taken it. So my wire got deleted. So any digital pin you can take it over here. So I have connected it on the 12 number pin. So now you can see LED properties over there. You can see LED is connected with one wire. So the connection, that is also important over there. So LED one connection, that is C, that we can see it over here, that is A, and this one is a C, LED 1C. C connection is connected with the ground. So you can see C connection is connected with the ground, and the wire color is also that is visible, that is green color. So that color I want to change it, and I want to make it black, because that should be a ground wire and that is black color. In the same way, LED 1 terminal that is connected with the resistance 1, that is green, so that we can change it over here green to a red wire. So that I'm going to make it a red wire. So that we made it. Then after that, we are going to use R1, this one, that second wire that is connected with the 12 number pin with the Arduino, that also we are going to make it red. So those manually attribute, you have to change it for changing the color and all these things over there in the board. So after doing this, what next we have to do it over here? These are the attribute of that specific connections, all these properties of that specific connection over there. So what next we have to do it over there? We have to write code. So how we can do that coding part? So that we are going to discuss over here. So when we talk about the coding of that specific board for that specific LED, so we have to go to the sketch. In the sketch, what next we have to do it over here? We are going to use, first of all, in a void setup, we have to define pin mode, like which pin we are going to use it and what are the properties of that pin. So we are going to use over here, that is 12 number pin, and that is the output pin that we are going to use it over here. So first, what we have to do it over here, we are going to use pin mode, we are going to write it, and over there we have to give the name of that pin number that we are going to use it, that is 12 number pin, and that we have to write it output. So that syntax, when we are going to write it, by default you are going to get the hint over there. So like this one is the output. Then after that you have to use semicolon. That is C++ programming that we are going to write it, that is Arduino programming that we are going to write it over here. So now after defining that pin number, that is 12 number pin as the output, we have to go over there, move ahead over there, and we are going to use over here, that is output. Mean we have to make pin high and low. So how we can do it? For that we have to use the digital. By default you are going to find these details, so we have to use digital write. So this one digital write we have to use it, and we have to use 12 number pin, and we have to make it high or low. So automatically, as I am going to connect that comma, so automatically you are going to get what should be over there, high and low. Mean you are going to get advantage of programming guidance. So those help out icon, you will able to see it, and you will able to select what you want to make it high. And then after that we are going to use some delay. So delay function you are going to get it, and in the delay I'm going to make it 100 millisecond. Then after that again same block we have to use it digital. So only one word we have to type it. After that you will able to find this option over there. Recommended is this one, or you can write your own also. So if you want to write with your own, that also you can write it, and you can use that pin number, and you can make it low, then semicolon. And after that you have to use again delay. So delay that I'm going to use it over here, that is 100 millisecond. So whatever delay we are going to use it in the Arduino programming, that is coming in a millisecond. So if we are going to write 100, that means that is in a millisecond, 100 millisecond. So this one is a simple code. We have written it for 12 number pin that is high, and 12 number pin that is low for 100 millisecond. So let's start simulation. Let's check it out. This code is working fine or not. So for that we have to click on the play simulations. So that simulation we are going to play it over there. So as we are going to play simulation, you can see LED is blinking, but we are not able to see it. Let me stop it. Let me increase that delay so that we can see it more clearly over there. So that we did it. And now we are going to start simulation. We are going to check it out. Now you can see LED is blinking with the interval of 500 millisecond, and that simulation is working. So the LED is over here with the green color. So whatever color you want to change it, for that you have to go to the diagram.json file. In the JSON file you have to do few modification, and after that you will able to do it. Then you can save your project also. There is option of save. So you can click over there save, and there is option of over here log project, save a copy, download the project in zip format also. So if you want to download it, and further also if you want to open it, then also you can do it. Like I'm going to download it. So that sketch is being get downloaded over there. You can see show in the folder. I'm going to open it, and after opening it, what you are getting it at the output. So you are getting that sketch. Sketch means the Arduino code that is being get downloaded over there, and the diagram in a JSON file, whatever we are using it, and the project the text file also you are going to get it over here. So all these things you are going to get it over there when we are going to download it in the JSON format. So that we can do it over there. So if you want to unlist it, that also you can do it, and you can sign in also over there. And all the detailed document you will find it in the document page over there. So like over there in the documents about this board, because we have to use some code, you have to modify it over there in the diagram also. For that you have to refer the document. So the detailed document you can check it out over there. Like if you want to open any kind of simple code, blink LED in the ESP32 board, Arduino Hello World, monitor the weather on the 1885, control servo motor. So these are the different projects you will find it over here. So using LED you can start it, mistake, what are the possibility over there, the mistake, confidence and code, unique feature about this. So all these things you will able to find it over here in this detail. So these are the club and these are the guide over there. Like diagram editor, if you want to edit any diagram, so how you can edit it, adding a part, moving a part. So there is a plus icon. So this one is a detailed document over there for adding anything over there in this board, and rotating a part. This one is also very important. So when we are going to rotate by clicking on it, so select it, then press R. Using R, we can rotate that component in a clockwise or anti-clockwise directions, or you can go in editing over there also. You will find that rotate option. Deleting component, you can select it and press the delete button from the keyboard. Then you will able to delete it. Edit wiring, that I already shared with you how you can change it. Changing the color of the wire. That wire color also you can change it. Delete the wire. I mean directly select that wire and you can press that button of delete. And these are the shortcut from your keyboard, like zoom out, zoom in. For that directly also using shortcut command in your keyboard, like plus, minus, rotate the selected part, R, delete part. Then open documentation, the question mark I said with you earlier, escape key, cancel any kind of wire, that you can do it, toggle the grid. Then the shift key, that can be toggle course grid, snapping while dragging. Alt also you can use it. Then control also you can use it for toggle fine grid, snapping while dragging. So I mean you want to increase size, decrease size, redo, undo, that also you can do it. So that is about diagram. So that we have discussed over here: diagram, keyboard shortcut, start simulation, save project. So that also you can use it, because this one is not directly graphical user interface. Few keyboard shortcut we have to use it, and few basic simple coding, like few modification we have to do in the code also for the diagram representations. So these are the few shortcut of keyboard. So these are the power editing keyboard, like if you want to select any one, duplicate any line, so all these things you can use it over here. Then after that, debugging serial monitor, that is also very important. So Arduino Uno and Mega, when we are going to use it, so we can open that serial monitor also over there. For that we have to write in the code that serial begin. So if we are going to use it, then automatically serial monitor is being get open like this. So that is being get open over there. So 1885 board, when we are using it, then also you can use that serial monitor. So these are the code that we have to write it over here. So these are software serial library, we have to use it over here. Then after that, logic analyzer, we are going to use it over here. Like any logic we want to visualize it over there, like the scope we are going to use it. In the same way, the logic analyzer we can use it over here for analyzing any kind of logic over there. So any kind of PWM signal and all these things, that we will able to find it over there, all the properties also. Then the libraries, as I said with you earlier also, you will use a many library like Arduino library you can add on, and any other board that we are going to use it, that library also you can use it. Then MicroPython. So there are two type of Python coding that we are going to use it over here, that is MicroPython and Circuit Python. Those are similar kind of things, only few inbuilt functions is being are different. So when we are going to use Raspberry Pi, so we can use that MicroPython over there. So project structure, like we have to use import OS. So operating system we want to import it, that we can do it. Then we are going to use print also. And then there is one more MicroPython over here, REPL, REPL, that also we can use it over here, that library. Then there are some project example over there that also we are going to discuss later on how we can use those project. Then the circuit Python over there, so that also we can use it. So their project structure is little bit different as comparison to the MicroPython. So we have to use some different Adafruit libraries over there for the displaying or other applications. Then the simulator ESP32. So like earlier we have discussed that we can use ESP simulation over there. So ESP32 board we can use it over here. So over there we can do programming in the Python also. So over there in this board, this one is a development board that you can get it in the market, and there is many pins as comparison to the Arduino board. So over there, how we can use it, how we can program it. So first of all, we have to open it. Then we have to open MicroPython project, or we have to write code in a MicroPython, and then we have to upload it over there, and we have to simulate it. So we can simulate it using Arduino coding also, or using MicroPython also. Both option is available over there. So there you will find custom bin file. Over there you can modify it. So there are few examples that you will find it over here in the Arduino. So I'm just going to share with you those example also. And Wi-Fi scanning also, mean Wi-Fi connectivity also you can do it over there in this Arduino, I mean that in C++ language in ESP32. Then after that, I mean, you can connect with the Wi-Fi also, and you can send data to the cloud also. Then some micro Python example over there like NeoPixel, then RTC examples over there, Wi-Fi scanning example also over there. Then that is this one is a different development board of that ESP, that is company by default ESP development board, that also you can use it. So these are some add-on features over there. Wi-Fi simulation, like if you want to go with the ESP Wi-Fi simulation, that also you can do it over here. So now after doing this, that we can do it over here in this ESP board. So that is about documentation, like as I said with the Wi-Fi simulation. So when we are going to do, mean going to send data to the cloud, so for that we are going to use Wi-Fi. That's why we are going to use over here, that is ESP32 board. So in this ESP32 board, what we can do it, we can connect Wi-Fi also, and we can use Bluetooth also. So two option is available over there in this board. So over there we can set up a server also, inside server, web server also we can use it, and we can connect to the MQTT server. MQTT means that is being used for IoT application, like any sensor data we want to send it to the cloud, then we can use that MQTT server or MQTT protocol. So like if there is already available that MQTT server, so there are few open source MQTT server that can also be used over there for sending data or receiving data. So connect to the Wi-Fi. So any Wi-Fi available Wi-Fi we want to connect it, so that also we can connect it over here using this. So connect for Arduino, like if we are going to do programming in the ESP32 using Arduino IDE or in a C++, that we can do it like this. So whatever Wi-Fi name is available over there, like any hotspot name, we are going to create it, and we are going to connect with that hotspot with that ESP board, so that also we can connect it over there. Then after that, over there we can move ahead. So connecting from MicroPython, like if we want to program it using MicroPython, then you can see over here. So that network you can import time also over there, then connecting to the Wi-Fi. That is about coding in a Python. So first of all, these libraries we have to import it, like network library of the Python. Then after that, time library. Then after that, we have to write code in a Python in this way. We have to scan it. Then after that, we are going to check it is connected or not. So that coding also. So internet access, like about connecting the internet, so we can use like speed, all these things can be used in public network or private gateway, public gateway and private gateway. So installation, how we can install it, all the detail you will able to find it in the document. So if you want to see that traffic of that Wi-Fi, means sometime when we are going to use IoT protocol for research application, we have to check it out the packet also. like which kind of packet we are sending it, what is the protocol of that packet, what is the size of that packet, like if we talk about the security of that IoT devices. So for that we have to analyze the packet data, we have to analyze it. For that there are different software that can be used for analyzing all the data. We are going to send it from the software. Without hardware we are going to simulate IoT application using this tool. So this one is the one software that can also be used for analyzing the data. So in the same way, the software that is being used, that is Wireshark, that is so much popular software for analyzing data for security applications. So for hacking also that is being get used. In the same way, you can use over here that this one tool, that workbee tool for analyzing all the packet also, which one packet we are sending it from the virtual sensor over there in this tool and sending to the cloud, and whatever data we are receiving it from the cloud, that also we can see, like weather logging. So this one is a project over there that you can see it. I will share with you. So there are a few more diagram reference also, you will able to get it. Let me share with you. So those document is very important, that how we are going to use document over there. Diagram JSON. So these are different component diagram that you will be able to find it. So their reference also you will be able to see it. Like I'm just moving it over here about IR sensor, their properties, LED. Just take an example of LED. So in the LED you can see the description. The LED is being used over there. That is 5 LED. One is positive and one is negative. There is a two terminal. One is A anode, then C cathode. Then after that there is a color coding. So color, in this way you will be able to find it. So that you also you can use it. Label also that is mentioned over there. The flip you want to do it, flip option is over there, that also you can make it horizontal or vertical. And then after that these are the color that you can select it. So these attribute you can change it over there, and that you can use it. Analog write if you want to use it. Analog write mean if you want to control the brightness of that LED, that also you can do it. Simulation example also you will find it over here, like blinking and fading. So similar to all the component that we are going to use it over here, like Pico, Pi Pico. So this one is a Pi Pico board, that is Raspberry Pi board. And in this Raspberry Pi Pico board, the microcontroller that is being used over here, that is RP2040. That is very small microcontroller, and the processing power is more as comparison to the Arduino Uno. So that you can see it, that is based on a dual core ARM Cortex M0 plus processor, that is 264K, that is memory of, that is internal RAM, and flexible programmable input output, which is, I mean you can program using Arduino also, but you can program it using C++ and Python both. Pin diagram, when we talk about this board, you can see over here, like GPIO pin. When we talk about GPIO, it means general purpose input output pin that we are going to use it. Like in the Arduino, we are going to talk about the input output pin in a simple way, like digital input or analog output. But over there, we are going to use, that is a GPIO pins. That is general purpose input output pins. So now over there you can see it. So these are the digital input output pins over there that we can use it, like 26, 27. And when we talk about analog input channel, that also you will able to find it, that is 0, 1, 2. So mean 2, 3 analog pins you will find it over here. Positive power supply you will find it in the different format. Ground also you will find it 1 to 8. Mean total 8 ground pins over there. You can use it for different sensor interfacing. Then these are digital GPIO pins, more GPIO pins, that also you can use it. So when we talk about physical pin number of the ground pins, that you will find it over here. So other pin number you will find it over here. I mean any modification you want to do it, that you can go with the diagram .json file, and you will able to modify those pins also. Onboard LED is also over there, that is built-in LED, that is connected with GPIO pin 25 over there. So that we can program it for simple blinking code. So that code I will share with you later on, how you can bring any LED over there. Simulation feature over there, like processor status also you can see it, GPIO pins, USB also you can connect it, UART, all these features we are able to use it in this that Raspberry Pi board. So when we talk about Arduino core, when we are going to program in this board using Arduino, so that also we can use it over here. In the Pico, we have to use this code, and then after that we will able to see on the serial monitor and all that, whatever feature we want to use it, that we can use it. So MicroPython support is also available over there. So we can use MicroPython also for simulating that board, that is Raspberry Pi board. Then after that, there are different boards over there that you can see, potentiometer, servo, all the component you will able to see it over here, and their properties also. So I'm going to check it out 8 board. Like earlier I said with you, that is very small, low cost microcontroller development board. So in this 85 board, so over there you will able to find, you can see over here, there is a total 8 input output pins. So out of 8 pins, how many pins you can use it for input output? Like there is one ground over there that you will find it, one VCC. So 6 pin you can use it for input output, and one is a reset pin. So 5 pin we will able to use it for input and output. And when we talk about analog input, so there is a 4 analog input channel, 0 to 4, 0 to 3, 0, 1, 2, 3. Then after that there is a ground. Then after that there are SDL, SCL, meso pins. Then after that you can use positive voltage. This one is output voltage, and this you can use it for digital output. So these are analog input. You can use those pin in analog output, digital output also. So that is about pin diagram and their details also. You can get it over here. And coding, when we are going to do in this board, in the 1885 board, that we are doing it using Arduino coding, that is C++ coding. So these are the detailed attribute of this one board. Serial output if you want to display it, and these are the more properties about the simulation feature of this board. Simulation example also you will find it over here. So I'm just going to open one example that I'm going to use it later on, and you can interface any temperature sensor or RTC over there. So that also you can use it. So that is about 8 board. And when we talk about Arduino Uno board, like earlier we have discussed, that is Arduino Uno. So over there, these are the properties of this board. And when we are going to talk about the pin numbers, so over there, might be you are familiar with the Arduino board, 0 to 13, those are digital pin, and A0 to A5, those are analog pin over there. So these are the more attribute of all the pins that we are going to use it over here in this board. So how we can program it. So these are the processor and usability, serial monitor example code, that is simple blink example, like recently we were running over there in the simulator. Then after that over there, I'm going to check it out. ESP board. So ESP simulator. And over there ESP Wi-Fi, that we have already discussed. ESP simulator also we have discussed. These are programming feature over there that also you can use it over here. So now we are coming back to the other boards, that how we can program other boards over there in this simulator. So this one is a simple code, we did it. Now over there we are going back over there, and we are going to select other boards over there. So Arduino Uno we have selected it. In the similar way we can use Arduino Mega also, Arduino Nano also. Now we are going to talk about this one, ESP32 board, and we can use that this one board also, that is a Raspberry Pi Pico. So this board by default you are going to see it, that is hello world. So as we are going to start it, it will print on the serial monitor, that is hello world. So this one is a ESP32 board. So like as we are going to start it directly, so what is happening over there, that we are going to check it out. So that simulation is being started over there, and this one is a serial monitor that is being get open, that you can see it, hello ESP32. This one we have printed it over there, and you can see in a graphical way also, like whatever value we are printing it on the serial monitor, that we can see it in the graphical format also. If you want to delete something, that also we can delete it. That is very simple. We have used it over here. Now if we have to write any kind of code over there for this board, so in simple, the same way we are using in the Arduino, that we have to use it. So in the setup we have to define pin mode. So pin mode we are going to use it over here, like over there you will find many pins. You can see it, 32, 34, these are the pins over there, 19, 21. So let me use that 5 number pin that I'm going to use it. So you can use 5 number pin, and that we are going to use it output. On the 5 number pin we want to give output. Then after that you can go over there in the loop. In the loop we are going to use it digital write and then we are going to use 5 number pin, that we are going to use it high and low. So you can make it high, 5 number pin is high. Then the delay we are going to use it, and after the delay, that again you can use it, that is digital, right? That is the same coding we were doing in the Arduino. Same coding we are going to use it over here in the ESP32, that is C++ coding that we are going to use it, that we are going to make it low. And after that again we have to use the delay. So delay, I'm going to write it over here, delay, that I'm going to make it 500, so that we can visualize it also, semicolon, and over there also I'm going to make it 500. Then after that we can make it high, low, start simulation, and let's check it out what error is coming out. Restart the simulation and save it. Saving is very important. That project we have to save it every time whenever we are going to use it. Now my code is working over there. Simulation is running. So stop it and start it, but we have not connected any LED on the 5 number pin. So go to the plus button and we can take this LED and we have to connect it with the 5 number pin. So using Control R, I'm going to use it or rotate it. So Control R you can use it, or directly R button you can use it for rotating it from the keyboard. That LED I'm going to connect it. Let me rotate it one more time. So this one is a one terminal, that is ground. So ground we can connect with the ground pin. So ground terminal we can connect with a ground wire. Then after that this one we are going to connect it, that is 5 number pin. Where is D5, that you can check it out, this one. So that we have connected it. Now we want to change the wiring diagram and all that. That properties you will find it in the diagram. In the diagram you will see that ground wire, green, red. So that option is available over there. So I'm going to make it over here. That is ground wire, that is black. And after that we are going to make it this one wire, that is red. Now that color you can see it. LED color also we can change it if we want to change it. Then after that we have to check it out in the simulation. The sketch we have written it over here. Now you can see it, LED is blinking. And if you want to print it, so over there every time you can do that serial print, serial dot print, and over there we can print what we want to print it. You can mention it in the double quote, and over there we can mention that LED on, LED on. And after that same we are going to copy it over here, and after LED is turning off we are going to print it LED off. Their status also we want to print it LED off. These things we are printing it over here, and you can mention Allen also, Allen in new time. So after this it will print it in a new time. So then again we are going to start simulation. We can see on the serial monitor, automatically the serial monitor is being get open when we are going to start simulation. So let's see. There is some error over there. So what is the error? We are going to check it out. So you can see error also, you can identify what is the error over there. So the problem is over here, LED on it, but semicolon we have not. Semicolon. To over there also you have to mention semicolon, and then go down. There is no other error. So all error is being get resolved. Now going to check it out. Start simulation. So earlier there were 2 errors. So those errors we have resolved it. Now we are going to check it out further. If there is any error, that also we can see it. So now simulation started, LED on, LED off, LED on, but there is no space over there. So that we can modify it in the coding. So LED on, after that if we want any space, you can increase the size, automatically we will be able to see the space. So this one is a simple coding that we can do it in a C++. Now we are going to talk about the Python coding, how we can do the Python coding. Now you can see there is a space, LED on, LED off, LED on. So same indicator we are getting it on the serial monitor. So in the same way we can do programming in this board also. Now coming back over here in this board. So over there, we are going to talk about the Python coding. So this one is a board that we are going to take it, and over there we are going to write code in a Python. So all the setup is same. Now we are going to use Python coding over there. So how we can do the Python coding over there? So for that we have to use simple example code for this. So I'm going to take an example code, this one. So this one code we have to write it. So first of all, what we have to do, we have to use library import time, and from machine import pin number. So two things we have to use it. Then after that we have to define pin number, and we have to use this one code. So let me go to over there. So I'm going to use this one. Now you no need to define serial begin and all that. Automatically it will print it on the serial monitor whenever we are going to start simulation. So first of all, this one is the internal library in the Python. So no need to define that serial begin or print all that. So automatically it will print it over there. Then there is option of import time from machine import pin number. So we are going to import pin also, that which pin we are going to use in this board. Then after that we have to define pin number. So we are going to use 2 number or 5 number pin, we can use it, whichsoever pin we are going to use it over here, that we have to define it pin output. Then after that we have to use LED value 1 time sleep, that is delay. The LED we are using, and then we are doing it like this. Then the LED dot value, that is 0 mean LED is turning off, and value 1 mean LED is turning on. That is the delay. While true mean it will repeat for infinite time. Then we can start simulation. So like over there we are going to use time dot. Yes, so automatically you are going to get hint over there which one we are going to use it over here. So in the same way we can do it. So now we are going to start simulation, but before that we are going to add one more LED. So that LED we are going to connect it on the 5 number pin. So these are the pins over there for D2 5 number. So 5 number pin I'm going to connect it over here with the LED C, LED 1C, and so first of all we have to connect with this output 5 number pin, and this one pin we have to connect with the ground. The C number pin is a ground pin. So where is ground, that you can check it out. There is multiple ground. So I'm going to connect it with this ground. So that connection I did it over here. So if you want to do zoom in, that also you can do it as per your requirement, that you can do it. So these are the different views over there, like toggle grid. So that grid view also you can see it over here. So all the dimensioning also you can see it over here in the easy way. Full screen mode also, like if you want to use this circuit diagram and you want to make it full screen, that also you can do it, like we did over there, the connections like this. So wiring we did it, you can change color, whatever you want to do it, or you can see all the pin numbers in a detail. So automatically it is being get shifted. So now what next we have to do it over here, we are going to start that simulation. Exit full screen, that also we can exit it, and then after that we are going to start simulation. So as we are going to start simulation over there, I think wire got disconnected over there. So let me connect it again. D5 pin we are using it. Now we can start simulation. Let's see what is happening. So some error is coming over here, like recent call, ESP module, help. This one is running over there, but LED is not working over there. So it is printing that value, MicroPython to stop it. So Python is running over there, the pin number, or there is some issue over there. LED, yes, some mistake to check. Pin is output, LED value high, pin is already defined. So in the JSON you can see properties, ESP, that is green wire, then after that ground wire that we have connected it. Let me check it out there. Example of ESP 32 volt. Distance reference. This one we have did it recently. That is programming in a C++. Import network time machine. So that is same thing. That is the library. We have imported it over there. Let me import. So over there, let me check it out again. Micro Python code for ESP. Micro Python. So this one is the same code I think we have used over there. Let me check it out. This one code. So we have used over here. Not this one. This one we were using over there. So some issue were occurring. So let me use again another code to check it out. So import time, that we did it. Then after that import pin number, print LED. So that we have to use it pin 2. So that we have used counter, that timer also we can use it over here. LED on, time, LED off, LED sleep, that counter way also you can use it. That is same way. So what is the issue over there in the circuit? So let me check it out. Is it working over there or not? Pin number 2 we are using it over here. So there is an inbuilt LED over there that is on pin number 2. That is blinking. LED is blinking, that you can see over here using that counter. Now this one is working with a counter. So without counter also it should work. So let me check it out. So over there we are going to use pin number 5 is comparison to this. Check it out. Lead. Now LED is blinking, that you can see it over here using time. So in that, use it over here, you can program it, and these are the libraries, those are imported. First we have to import it, and these are the syntax, those are inbuilt syntax that you have to follow it. If you are not going to follow those syntax, you will face difficulty while running the code. So in the Python also you can do coding, but the way of using Python, that is very important, how we have to use it. Now we are going to use over here another board, that is Raspberry Pi Zero board. So how we can do program over there in that board using Python coding. Raspberry Pi Pico board. So this one is a Pico board. So by default we are going to print it over there. So we can do programming over there in this Pico board in the two ways. As I told you earlier, you can program it in the C++ way also, and you can program this board using Python also. So right now we are programming it using that C++. So that is the same syntax that we are doing in the Arduino, and we can use over here this board as a Python also. For the Python, I'm going to discuss. So this one board we are going to use it with Python. So go over there, Pico SDK, circuit Python on the Raspberry Pi Pico. So this one I'm going to open it. Now over there we can use that Python programming. So let me open that example over there. So this one is a simple example of LED on off. So same way from these are the library or pin number, we have to import it from the machine. Then time we are going to import it, that is the internal library over there in the Raspberry Pi, that Python SDK is being installed over there. And then after that you can see hello print, we are going to print it, and 5 number pin we are going to take it for the output. So these are the pin number, GPIO pins. So you can see these are the GPIO pin 5, that is ground. These are the other pins. So you can use any pin, whichever pin you want to use it. So we have connected LED on the ground terminal and the 5 number pin. Then that is pin 5 output, while true LED toggle, mean LED will turn on and off after the interval of 0.5 seconds. So let's start simulation, how it will work. So now you can see LED is blinking over there. So this one about that PIO debugger over there also you can check it out if there is any error. So that also you can troubleshoot it over here. So that is about diagram. In the diagram also, if any modification we want to do it, that also we can do it. All the pins, all the GPIO pins, same way like earlier we did it. Their color also we can change it. And this one is a simple code that we were using over there. So there are some, when we talk about this tool, so there is more functionality, but you should know that how to use this one. So what are the functionality and how you have to write code. If you are having already built it code based on this board, that code also you can try it. And when we talk about component over there, you will find many component like earlier we have seen. So any potentiometer we want to interface it, any other board we want to interface it, that also we can do it over there. You can use accelerometer and gyroscope also. In Coder also many more components are available over there that can be used in the Raspberry Pi also. That component can be used in this ESP32 board also, and that project, whatever project you are going to make it, that also you can save it. And many example also you will find it over there. Like these are the few examples over there that you will find it. Like this one, I'm going to open it. Like national anthem, we have to play it over there in this board. That also we can play it. So in that way, that also you can do the coding over there in a C++, and you can play it on this board. And similar way, few more example over there, like this one is a piano. That piano also you can make it using Arduino board. Let me play it. I'm not so much good in the music, so if anyone is having good understanding with all the notes, they can play any song also over there. So that also we can do coding over there, and we can simulate it like this. So all the pitch file is being used over there, different notes for different buttons. That also we can use it over here. So that is about few more example over there. So plenty of examples, inbuilt example also you will find it over here in this board. Like any game you want to play it, any servo motor you want to use it, so that also you can check it out, and you can make any kind of project over there in this simulator. So now I'm coming to the question answer. If any participant having any kind of queries, so you can feel free to ask over here. So further also, if you're having any kind of doubt, so you can feel free to contact me. These are my contact details over here. So this one is a one tool that I shared with you over here about this new simulation tool. So that is very interesting. If you want to do any kind of circuit simulation, you want to do it, and if you want to share with us amongst the students, so they will also get benefited using this tool. So any kind of IoT application also can be done over there. That is advanced one, because in this in the very short duration, it's not possible to share all these things in one session. So that is about the beginner session. You can try it with your own, and you can explore with your own also, because all the resources is available over there. So now I'm coming to the question and answer.